Okay, so today, welcome to our talk. It's going to be Mike McCune. Did I pronounce it right? No, I didn't.
Pousty? Did I pronounce it right?
That's close enough.
McCune's fine then.
Say it again.
McCune.
McCune. Do I have to say it with like a Scott? McCune.
McCune.
Get in my belly.
You better.
All right. Yeah. And I'm Steve. We're both on the. I'm on the OpenShift team, and Mike, who's suddenly shrunk, is on the DICON team internal to Red Hat. Should we call it the Red Analytics team?
We are an emerging technologies group.
He's in the emerging technologies group. Hence why he came up from the table. So Mike is one of the engineers working on a lot of the big data stuff that we're going to be showing today. I'm just here to look pretty. The brief introduction of how things have evolved over time, then we're going to talk about what we have now, and then we're going to show videos of this in practice and talk to it. And the goal is to have, in case you couldn't tell, we're kind of informal presenters, and our main goal is that everybody here has fun, okay, with a capital F. So assumptions, you have written a web app at some point in your life. Is that a good assumption? Of course it's not a good assumption with you. I can't assume anything with you. I don't even know who you are, but I've already given you more sass than I give most people. So is that a good assumption with everybody else? Yeah? Even if it's like PHP with a little bit of JavaScript and it had a blink tag, you're in, all right? And then you know some basic of Spark. You guys know, you've ever heard of Spark? Okay, you know the basics of, and you know that it does data processing and makes your life better and makes some people not grow their hair back in. You guys know that about Spark? That it's just awesome? That's all you need to know. Okay, so where are we coming from? So this is where I get to speak, because I'm actually, despite my youthful appearance, I am actually the older one in the group here. How many people remember this? Yeah. And how did it smell in that room? Bad. Because this is usually located somewhere in the depths of a computer science or statistics department, and you were staring at a green. I think these are VT 3200s. I think maybe they're what? These are the 200s? Yeah, you outclassed me on that one. Now I have to up my game now. So this is how we used to do most of our computing, right? And so this is actually what most of us looked at. Is that right? Yeah, pretty much. When you were looking, you probably was all green actually when you were looking at it, but it looks something like this. Does anybody recognize that prompt? Actually, this will give you a better idea. Does anybody recognize that? This is how we used to do big data. Does anybody? Nobody recognizes this? Anybody have a statistics background? Did statistics in college? Pre-1990? That's SAS. That was how you did statistics, or you wrote Fortran code. But basically, most people who did statistics, this was how you did statistics. You used SAS on a mainframe. And this is big data. We have how many? 5 entries? That's big data right there. That's what I'm talking about. Like your data, you were actually usually hand coding in or reading off a tape the data, right? And it would take you a while to load it up, and then you do some procs, and this is your output, right? So this is how you're actually dealing with everything that got spit out from your analysis, right? And so what about apps, like web apps? What were we doing for web apps at that time? Right? So there was no web. So we had statisticians. That's what big data people used to be called, was statisticians. And you basically were sitting at some sort of VAX terminal, running these long-running jobs, and then you'd go up to the window and knock and say, is my print job done? And then you'd have this stack of paper that you would use. I'm skipping the whole card phase. I was not alive I was alive, but I never used cards to program. I'm sure there's some here who have. But there was no web apps back then. So there was no convergence of the web area with big data, and big wasn't so big, okay? So then we step into what I'm considering the next era. Does anybody recognize this? Can you see that little thing up on the top? What does that say? S+. Anybody here use S+? Has anybody here done statistics? Yeah, exactly. And that's you're my go-to guy. So S+, how many of you have heard of R? Right. This is the precursor. S was the actual precursor to R. S+ was the commercial version of S. S came out of Bell Labs, where everything good seems to have, Bell Labs and what's the one in Xerox PARC. Those are the 2 labs. Everything good in the world seems to have come out of those. S came out of that. And then there was S+, and then I was always excited because they finally had a Windows version. So I could actually copy and paste data sets in and things like that. And this is how we would do our statistical analysis. When we needed to do big data, you would do it through here. And you would try to get as much RAM on your machine as possible. You would not use Excel. This is no. There are people there who try to do statistics in Excel. There are many reasons why you never should have done that. And you should have shame if you still do. Although maybe they fix some of their errors. But it's known to be broken, like on their random generator function. And this is web apps. It's pretty exciting, huh? Right? This is a page I helped build back in about 2000. Right? So that's the time frame we're talking about in here, the early 2000s. But actually now, I think we actually live in a golden era compared to those other two stages. So we've had some great development since that time. And I hate that all the bullets come up once because now everybody's reading. But people figured out how to make commodity hardware do great things. Right? Used to be when I was trying to do statistical analysis, I would go to the Dell or the Gateway site. And does anyone remember Gateway PCs, the cow? Anybody under the age of 30, you're excused from that exercise there. But you would go there and you'd be like, how much RAM can I get? Ooh, and how big is that disk? Ooh, I gotta try to get it. Like $5,000, $6,000, and you would custom order it. Or like when I worked in that lab, the Yale Statistical Laboratory, we got a terabyte. We were so proud of ourselves because we got budget to get a terabyte SCSI RAID array to attach to our server, and it was $10,000, right? And it was special ordered for Dell because of the whole thing. But now, that stuff is all gone. People buy boxes and they do all sorts of really interesting things with really commodity hardware. Distributed software has gotten better. Back then, it was a Beowulf cluster. Did anybody ever run anything on a Beowulf cluster? Yeah. So that was like the high priestess, the high priest and priestesses of computational stuff. They were like, I set a Beowulf cluster up with a whole bunch of Nintendo boxes. Like that was the stuff. They worked with Beowulf, and everybody else just stayed away from it because it was completely nasty. And now we've actually gotten to an age where distributed software is kind of what we all expect, right? We expect it to be clustered. We expect things to be across multiple machines. Programming languages have gotten a lot easier, I would say. I don't know if everybody agrees, but I think they have. CS has put effort into statistical libraries. So what I mean by this is, when I used to try to do statistics back in C, back when I was doing stuff, or my favorite language actually, this is where you can tell I'm not the engineer in the room. My PhD is in ecology, and I was doing most of this stuff. And my favorite language was Delphi. So rather than because object-oriented Pascal, how can you go wrong? That is like the best thing ever. So I was buying not the recipe book in C, I bought the recipe book in Pascal. But if you needed to do statistics, basically what you were doing is you were copying those recipes out and like trying to make sure you get them to run right in what you were doing. Now, almost every modern language has a whole set of libraries that can do a whole bunch of advanced techniques, and the browser has grown up a lot since then, especially within the last 5 to 6 years, right? So what does convergence look like? Did you put this one in? I love it. Except it has some nationalistic overtones. Ignore that this has nationalistic overtones, and it's just trying to emphasize it involves OpenShift and you, and some of the work that Mike is about to now show off. So, this is yours now.
Right,
Mike.
yeah. So, yeah, I'll back up for a second here. Like, what does convergence look like? And for me, as the developer, OpenShift has been a great platform to kind of build these applications on top of. So I put this in here not to elicit some sort of jingoistic, response from the audience, but to say, hey, OpenShift and you is where this can really start to converge. So for people, everyone kind of raised their hand for, they've developed web apps. So I think for web developers, coming into an ecosystem like OpenShift is a lot more natural, right? We're going to start developing this application that's kind of in the middle here, and there's all these cloud-based technologies that we might want to use. Well, they're not all cloud-based, but, we might need to use Ruby, or we might need to use Spark, we might need to bring in Postgres, If you're used to building web apps, you're probably used to connecting remotely to databases. You're used to consuming resources that are already loaded into a server somewhere. So this is going to be a very natural transition for a lot of web developers. And we start to come into the idea of kind of hammering your application into shape. What does it look like when you're going to bring it into an OpenShift cluster? And I'm going to thank my colleague Kim Palko back there for giving me this great ingest, process, publish language. And this is something that I love to look at when I'm designing an application that's going to be created for doing this type of analytics work. The first thing I think to myself is, what is this kind of ingest, process, publish methodology that I'm going to use? And what I mean by that is that usually if you're making an analytics application, first you're going to need some data, so you're going to have to figure out how is that going to be ingested into your application. Then what are you going to do to process that data? What kind of transformations will you do on that data? How will you filter it? What's going to be the end results of the processing you're doing? And then where will that be published? And in the sense of of a web application, like we have with this kind of technology stack here, the endpoint might be some sort of HTTP. It might be a web page that your users would end up getting to and kind of manipulating. But it doesn't have to be that. You could also string together a series of analytics applications if you look at ingest and publish as kind of like pipe in and pipe out. And what you're going to see when we start to get into the demo is how this comes together on OpenShift and how it's almost like playing with Legos or bricks or something. You can just kind of put everything together and remix it if you feel like it. And so this whole pipeline will kind of help you to achieve that. Another really big thing that, and again, as web app developers, this is kind of, this is almost redundant to say, but we're probably going to be building as a team. There's going to be a lot of different people involved in what you're doing. You might have, the data scientist who's always barking at you, telling you didn't do it right, and your hair gets all gray, and you even though you're younger than him, and you might look better than him, But anyways, so
hypothetically speaking,
yeah, this is all hypothetical.
Thanks.
So you're gonna have to be aware of how do you build as a team, and if you start to use OpenShift, what does it look like to build as a team on OpenShift? Because, in the past in web dev, it's like, all right, I need to deploy my application to the server, so can someone give me the keys? What's the passwords I need to push my application there? And oh, I messed something up. How do I get into the database? Can someone give me the password to the database so I can get in there? And moving into OpenShift, we start to treat resources a little more dynamically. They're much easier to swap in and swap out. So I don't have to go bug the Mongo team if I need to just get a little Mongo instance up and running so I can test, the Spark component against it. I can just create that in my project and work on it, and then I can go bug the database guys later. And you'll see when we get to the demo how this kind of fits in, how these pieces kind of come together. So now we talk about taking it to the next level, bringing it to OpenShift. And this is where what you're seeing here is kind of a model of how I might start to build something in OpenShift. And how many people are familiar with OpenShift here? Show of hands.
If your hand doesn't go up, you didn't pay attention to any of the talks at any of the keynotes.
All right, how many of you have actually used OpenShift version 3? Okay, cool. So a lot of people. So you're probably all familiar with the concepts of projects and users and roles as you come to OpenShift. So what we're looking at here is part of our team. They've created two separate projects. There's a project for the front end where our Node.js application is living, and there's a project for the back end where our REST and our analytics components are living. And in this case, we've got a mock server set up in our front end part. So we don't have to bug the guys on the REST team. We can just kind of run with this mock server. And eventually, the arrow on the side here is kind of indicating that in the case of HTTP or HTTPS endpoints, the REST project could start to expose their resources to us on the front end team, and it becomes very easy then to pull the mock server out of the way and just plug it right into their project and see, all right, are we working? How is this coming together? And then we'll kind of see, how do we go even further than that? So this brings us to a case study of an application that.
Can I bring something up about this before the case study?
Yeah, please.
As the grumpy, ugly.
Do you want me to help you up? Are you okay?
Thank you, young whippersnapper. So the other thing, though, I want to talk about what this actually also brings for the data scientist to this, right? So Mike's been talking as the web developer, and that's been nice. But I think what the nice part is here, as the data scientist, and we're not going to probably show it in this demo, but if you go to one of Mike and Will's talks, you'll see an Jupyter notebook. Does everybody know what Jupyter is? An IPython, used to be called IPython. It's a tool that I can do data science with, or I can even actually plug R into Spark. So it's no longer, and this is why I was trying to emphasize it in the beginning, it's no longer, oh, I've got my laptop, I do all my work on my laptop, and then suddenly somewhere in a completely different space, I've got to somehow translate this into something that the web developers can use. What we're seeing here, and this is the convergence, is we're going to be running our Spark cluster and all of our web pieces in the same infrastructure. So I, as a web developer, or as a data scientist, or we can sit together. Like I can be using the exact same Spark cluster that Mike's going to be using, that he's going to be calling into. It's no longer this, oh, I'm going to work over in this silo. Okay, well, now I'm going to somehow figure out how to get this into this silo. It's we can actually both together work in the exact same space, starting to use even some of the same languages. So I might be even working in PySpark on my machine, talking to that Spark cluster, and I can say, oh, Mike, I'm done with it. Here, take it. And he can just take it and put it right into his web app, spin up a pod with it, and away he goes. Right? So what we've gotten to is this place where everything's starting to run in the same area. That's why it's golden. Do you feel the glow? You should. All right, so let's go to the next, the case study.
Well, so one more point on what Steve's saying too is that, yeah, we can converge these things into the same projects and we can use the same resources there, but another real powerful thing about OpenShift is that, let's say I'm working on just the front end. So all I'm doing is app stuff, and Steve's been developing some great analytics for us, right? When it's time to bring these things together, Steve can share the templates that he's been working on to create the resources in his OpenShift project. He can just hand those over to me. I can run them real quickly, and now I've got the same infrastructure that he has set up in my project, and it's not affecting any of his work. We're not even sharing the same Spark cluster at this point. We're just sharing the same infrastructure. And I'm going to kind of show you how some of the tooling that the group I'm working with in Red Hat has been creating kind of makes it easy for us to then kind of spawn these Spark clusters wherever they're needed. And it's just another resource at that point. It's like, you want a database? Grab a database. You want some Spark compute? Grab some Spark compute. So Ophiclide is an application that my colleague Will Benton and I put together. And it's really meant to showcase this workflow. How do you bring these things together? And I'll just go over, this is kind of, what does it do? What does the architecture look like? So at a very high level, what this application will do, it'll use Word2Vec. And anybody here familiar with Word2Vec?
Almost everybody was a web developer. Almost yeah. So
Yeah. Okay.
Almost nobody knows Word2Vec.
So I'll go through a little bit about that too. I think the next slide's about that. But so this application will take text data from online, from an HTTP endpoint. It will bring it into the application and then use Spark to vectorize all the words that are contained within that text corpus. And then from those vectors, what you can do is you can create word searches to figure out kind of synonym values that exist within the corpus. So I might say, this is the name of a character in this novel. If I put that back into my synonym search, what comes back out? And it will show me other characters who are kind of similar to that. So that's kind of what it does at a high level, and this is what it looks like architecturally. So all the way at the left, we've got the browser component that our user is going to interact with, and we've also got text data that just exists on the public internet or accessible from our OpenShift installation. And then this block over here, it says Kubernetes, which is like the underlying layer, but this is all deployed in OpenShift, and we've got a Node.js component, which is a server serving the browser portion. And then we've got a Python REST server that the Node server is talking to. And that REST server is managing all of our jobs that are going to Spark. So every time a request comes in from the user, it gets piped down to this REST server. And then it creates a model and does some processing and stores the model results into a Mongo database so that we can use them later to kind of, to speed things up. So what is Word2Vec? And this is kind of an example here. If you imagine that these dotted lines are kind of the vectors that get produced after it scans the text corpus, what you're seeing at the bottom is kind of like some of the power of what you can use Word2Vec for. And so, let's say we have this vector for Spain over here, and then we also have this vector for Madrid. And you can see at the bottom, if I take the vector for Madrid and I subtract the vector for Spain, and then I add the vector for France, what I'm going to end up with is a vector that's very similar to the vector for Paris. So, this doesn't necessarily mean anything to the computer, but what we've seen is that, somehow I've been able to use simple math to kind of determine, two capital cities based on this, based on the corpus that we've, ingested. Maybe you read all of Wikipedia or something, you pulled it all in and processed it and create a model out of it. So these are kind of the things you can do with Word2Vec, and I'll show you kind of an example of how this works within the framework of the application we created.
So just while Mike's starting that up, Word2Vec is the name of the statistical technique. Okay, it's not some particular software package. What he's been explaining is a statistical technique, takes a big body of text, takes each word in the text and looks at occurrences next to words that are next to it, and then based on that can form relationships about words.
Right, and it will create multi-dimensional vectors for each word based on the processing model that it's created, and then those dimensions get reduced, and you can start to make these interesting comparisons.
Okay, so you guys are all the web developers. You want to implement that now? You ready? We explained it to you. You ready to go? So this is the point again about that benefit, right? Like, so I, as the data scientist, can come in and set this stuff up. But the other part about this that's a benefit to me as a data scientist, there was one of you in the room, is that right? Yeah. The benefits to us, too?
Well, you're doing textual analysis at this point, right?
Yeah, but do you do this kind of stuff?
No, I support it.
Okay. So you and I, buddy, mind meld. The benefit to us here, and what your data scientists will like, is have you ever heard of statistical overreach? That's what happens when we put statistical techniques in the hands of you. And you're like, oh, I know word2vec now. Let me do whatever I think I want to do. It's like when people take regression analysis and they regress like skirt length against stock prices, and they're like, oh yes, skirt length causes changes in stock prices. You've taken a technique and just used it completely inappropriately. And so what we'd like to prevent, this is like I get to feel like an ops person in this model, which is, no, you do not get to do whatever you want to do with my statistical model.
Yeah.
But I can work with the web developer and lock down what's actually available so that the end user does appropriate things with the statistical model. And we'll see that here.
Right, and I don't necessarily have a deep understanding of word2vec, but from working, with the data scientists, I've learned more about it. I've, through implementing it, I've needed to understand, what does this data look like? How do we express it to the people who are looking at it? And so, yeah, I'm going to do the wrong thing, right? If you give me that technology, I'm going to do the wrong thing with it.
Right.
But if I got Steve here to kind of keep me in check and say, hey, look, why don't you use these algorithms? We can start to really make something that is greater than the sum of its parts. So what we're looking at on the left here is the OpenShift console, and on the right is my terminal. And so what I'm going to start by doing is creating a project within OpenShift. Okay, great. So we created the project. I'm going to click into it. And now what I'm going to do is I'm going to create the objects necessary for us to build some of these Spark clusters in our project. And this address here, radanalytics.io, resources, YAML, is a file that we've created that has all the objects that you would need to load directly into your OpenShift instance to start creating, Spark clusters. Now, I'm also loading all these objects for the OFACLIDE application, and I'm going to start building the apps in OpenShift. So the training module is our REST server that I talked about before, and the web module is the Node.js front end. And so I'm going to have OpenShift build it for me so that later on I'll show you in the next demo how we can use that to kind of get some CI/CD type behavior from OpenShift. So I also need a Mongo database for this, like we called out in the architecture diagram. So now what I'm doing is I'm instantiating the Mongo database from the command line. And you can also do this through the project catalog or the add to project menu. There's a graphical menu you could go through to spawn these things. But for the purpose of this video, I'm just kind of showing how you might do this all from the command line if you just had this OC tool to access OpenShift.
Once it's done spinning up Mongo, can you pause the video for a second?
Yeah.
Okay, so I have a laser pointer here. I think, right?
Cool.
Oh, I think we do. Is that right? Okay, I need to actually go back a little bit in the video. If that's okay. Is it here? Okay, see this right here? This one command that did all this stuff behind the scenes? That's how much it takes to stand up a Spark cluster. How many of you have stood up a Spark cluster before? How many days did it, and didn't use Red Hat, didn't use the Rad Analytics project? Okay, smarty pants, you're the engineers working on it, stop. So how much fun was it to stand it up for production? It's the first time, right, yeah. That's exactly what I'm talking about. So this, as a web developer, how much do you want to take, if the data scientist says it's not fun standing it up, as a web developer, how much fun do you think it's going to be for you? Yeah, not much. That is the power now, and this is back to the power of like declarative model. So you were in my workshop, we're establishing the truth of the world right there, and the cluster is just going to make that happen, right? And so that's the power to you of this stuff converging also, is you can have the ops people or the data scientists make that truth, and then it just spins up the right way, okay? So now you can, there's any questions on that? Actually, we didn't make this clear at the beginning while this is catching back up. Mike and I are actually very, 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 very informal, in case it wasn't obvious, painfully obvious. So if you have questions, please ask them while we're going through, rather than waiting till the end. Because if you don't understand it, there's probably other people who don't understand it as well, okay?
Yeah, there's no, the live demo is kind of over at this point, so yeah, feel free to interrupt. So, yeah. Well, so the question is, if we start talking about chaining together analytics applications, are there any recommended tools for kind of putting those things together? It's going to really be dependent on kind of the architecture that you're creating internally, right? So I come from a heavy background working in OpenStack, and there's a lot of REST servers and whatnot there. So for me, what might look natural would be to set up some REST servers, REST endpoints that could talk to each other. And that might work for some use cases where maybe you don't have a lot of data to pass back and forth, or you're passing metadata between them or something, to, telling it where the object stores are. But if you start to get into something where you might need to pass more data, or you need a different methodology to communicate between them, you might use something like Apache Kafka or an ActiveMQ message bus, and you might set that up between the applications and put data back out onto that, and then have readers kind of watching for it coming across this in a streaming methodology. Well, so the way that we do it is we rely on the templates and whatnot that you can create in OpenShift, right? So you say, setting up Apache Kafka is kind of hard, and like Steve was kind of pointing out, setting up Spark can be kind of hard too, right? But we've turned those all into these reproducible templates. So really, setting up Apache Kafka is extremely easy for testing purposes within one of your projects. So if you're just working on testing an architecture out, you can use these templates to kind of load more complicated applications, then start interacting with them. So,
but if you're asking for like front end things, it sounds like what you were asking for is tools to manage, like I want to do stuff with my Kafka cluster once it's up, like I want a tool to manage that. Is that what you're trying to get at? Oh, so that's what Camel's all about. I mean, you should go see, if that's the thing that you're worried about, like gluing together a whole bunch of really big monoliths. Shame on you for ever writing a monolith, because obviously you should have known you were supposed to write microservices. But then, Fuse is what you're supposed to use for gluing things together, okay? Yeah, I think, isn't there a graphical interface to Fuse? I don't know, I'm not a Fuse guy. Middleware people, there is a graphical interface to Fuse, so we got you covered. You're good, man.
Okay, so this Oshinko CLI that you see I'm calling here at the bottom, right? The team that I'm working with at Red Hat, we've created a project that we call Oshinko, and there's several different kind of aspects to it. And this video, I'm using this CLI tool to kind of create our Spark clusters. There's also a web tool for this too, and you might have seen earlier it said like it's like Oshinko Web UI is another way to interface this, and it creates like a graphical interface to spawn Spark clusters. So what I'm going to do here is I'll just show you, this is, this tool is a little raw at this point, but I was using it in this demo to kind of show how you could just use another command line to create a cluster inside of your project. So what you're seeing here is, I'm kind of doing a little setup to authenticate myself, send it to my cluster, give myself a token, allow it to skip the fact that I'm running on test hardware with no proper TLS, authentication. And you can see as soon as I hit that, we started to create some clusters over here on the left. So we've got one master and one worker. And in general, Spark has this kind of master-worker flow to it, where one master and n many workers. And in this case, I just made one worker, just for the purposes of testing. But we could have added more, or we could even scale it up now that it's been created. So what I'm doing now is I'm going back to the templates that we loaded in earlier, and I'm going to start my Ophiclide application. And you can see I'm passing a parameter here. I'm telling it where the, should have stopped that. Where's this thing? So right here, after I created my cluster in Oshinko, it told me the connection URL for the master, and it's also giving me a connection URL if I want to look at the UI that comes out of Spark. And then what I'm doing is I'm taking that information and I'm putting it right into my application, so when I launch this, I've got a Spark cluster to attach it to. Now, in this case, I'm just using the Oshinko tooling kind of manually. I'm creating a cluster, I'm attaching it to my application, then I'm launching informing my application where it is, and then I'm launching my application. But there's other tooling that you'll find in our project, and this is all available at radanalytics.io. You'll see we have source to image tooling, so you can create applications that can be built from your source repository, and they will automatically spawn Spark clusters for you when you launch the app in OpenShift. So I'll let this keep going now. So now what we're seeing is it's going to start launching the Ophiclide application over here. And it's already up. It's already been, some of these images were already in place, or we built them, so they were already in place. It's pretty easy to bring up. And now what we're looking at is the Ophiclide web front end. This is that browser component that we called out before being, served by Node.js.
Yeah, this is the part where I, as the data scientist, say, wow, I hired a pretty bad UI team, that this is the UI I got from my web developers, but I'm glad it would have been even worse had I written it.
Thanks a lot.
You're welcome.
You just insulted the entire pattern fly team.
Well, it's just, could be a little prettier. Just saying.
Okay, so what I'm going to do here too is I'm going to start looking at the logs that exist in the training module, in the REST server, right? Because it's what I want to see is what's happening and how far along is it coming. So I'll start this up. I'll start looking at the training module logs just as kind of a sanity check. This is something that web developers like to. It's like, is it really doing what I think it's doing? Is it? I don't know. So I'm looking, you can see up here, this is a bunch of Spark logging that's getting going, and then now I can tell that my REST server is actually, getting a bunch of GET requests from my front end. So now, like I said before, we're going to start loading in some text data from the web. And one of our favorite things to do is use the complete works of Jane Austen taken off Project Gutenberg. So this is just kind of a nice, easy corpus of text. We can grab it from that URL and start to ingest it. So you'll see, I'm going to put it in there. I'm going to tell it to start training. So now the node module has now communicated, and you can see, it went by too quick, but there was a post request that came into my REST server. And what's happening now is we're watching the Spark logs as it starts to ingest that text, and it's reading it in right now. This is kind of why it's slowed down here. And it's going to start to create a model from the text that's in there. This is where the word2vec portion will come in. It'll make this model, and then when it's done making the model, it will store the model into a Mongo database so that we can refer back to it later. And you'll see that'll be the next part. And so, up here right now, we're still kind of in training mode, and you can see from the back end, yes, we're still in training mode. It looks like we're probably getting close to done at this point, and there's just some internal processing going on that doesn't really produce any logs, and we're back to getting our GET requests from the front end. Okay, this is a debug statement telling me how many logs were printed out in the training model, or how many words were processed in the training model, and we should see now it goes to ready over here. So I'm going to create a query, and I'm not super familiar with the works of Jane Austen, but through doing a lot of these demos, Mr. Darcy is a character. Anybody familiar with Jane Austen? Mr. Darcy is a character. But what we see here is that we've come back with a bunch of results. We've got Wickham, Collins, Bingley, Willoughby. These are other male characters who exist in the works of Jane Austen in kind of a similar role to Mr. Darcy. Now, again, I probably need to read more Jane Austen before I start doing these, but this was just kind of a simple test where we created the model from the works. I told it a word that I wanted to know the similarity of, and it's given me other words that are similar with kind of the vectors of how close they are to the word that I requested.
And again, this is where I was talking about that preventing statistical overreach, right? He is transitioned into a user role. The web app is done. Notice the user can only put in a word. They're not actually touching the actual model. We're not asking them some sort of weird parameters or anything like that. We're like, no, this is how we want to expose it, and they can only interact with it the way they did. And I, as a statistician, can be like, I can rest easy at night that no one's abusing my stuff.
Okay, so that's kind of the end of the first part here. So you can see how easy it was for me to kind of get that up and have a Spark cluster attached with it. I've gone from probably a raw idea that Steve handed me, or in the case of this, a raw idea that Will kind of came with, and Will, who's sitting in the back with the orange sweater there, developed the training module, and I developed the web front end for it, and we did this in parallel. So I was using the mock server, and if you remember that, if we go back to our kind of front end here, so I was working in the role of the front end developer. And so I just made, when we first started this journey, what we made was, is anybody familiar with Swagger or OpenAPI? So we created an OpenAPI definition, and we used that as the conversation point between myself and the data scientist. We said, look, as long as you make a REST server that adheres to this definition, and I make a front end that can read from that definition, we'll meet in the middle later when we're both done. So Will had gone off, and he was busy writing the REST and the training module part while I was creating the terrible-looking front end. So I probably should have spent more time on it.
No, you should just stop insulting me.
Thank you, Will. So I'm developing the whole time with just this mock server, giving me back like dumb responses, because I know what I need to get based on the REST definition we put together. And when it was time to bring them together, I just knocked out the mock server and plugged it right into the REST, to the REST server that Will had created. And since he gave me the templates for it and everything, I just deployed it into my project. I had Spark up and running real quick through the Oshinko tooling, put it all together. I plugged my Node front end into it, and because they're both adhering to the same spec, it just worked. So there were some problems that came up later, because when we initially laid the API out, I made some assumptions that, as a non-data scientist, I made the wrong assumptions, right? So we had to go back and revise the way that the REST interface looked between the two applications. But to begin with, they both communicated fine. So things that kind of helped our collaboration, and I was just kind of touching on this, Open API, that was a huge boon, and this kind of goes back into if you're creating these processes that are all going to kind of talk to each other, and if you're using REST, it's a great tool to help kind of make it easier for the teams to coordinate in a distributed fashion. In the same way, Docker templates really helped us out too, like being able to recreate images and just pass them quickly from one user to the next user. I could create an image for the web module, I could give it to my colleague, he could just bring it up right away and start testing with it immediately. That was really easy. And then, again, OpenShift, this similar kind of reaction. These templates that we could create made it very easy for us to communicate across projects. So if Steve has a complicated infrastructure setup, and I'm like, dude, how did you set that up? He's just like, take this template. I can run the template. It'll all be set up in my project, and then I can take my time and study the template and see, what was he doing. But this made it really easy for us to collaborate, because we didn't have to spend time kind of hemming and hawing about how the internals are set up or what our infrastructure looks like.
Or I set it up one way, and then I forget to document 3 steps in it, and then you set it up, or you set it up a completely different way. Like
exactly.
It just goes away.
And as most of you probably know, this happens all the time, where it's like, oh yeah, I had this big complicated setup. You just do these 2 quick steps.
Right.
And it's like, dude, you forgot the 5 steps in the middle.
Exactly.
So, but it's not all perfect, right? There are some things that require even greater coordination. And this, going back to the idea of using Swagger or Open API to communicate, API construction is not necessarily just an easy thing. And I'm sure for all of you who've worked on REST interfaces, you know that you don't write it once and then it's like, yeah, we'll never come back to the definition again. This will be perfect for all the time. So, I made some bad decisions. I didn't understand the depth of the data science work that was going on, so we had to go back and revisit that. That's something that, probably best when you start designing these applications, to make sure you have all the stakeholders together in one room kind of hashing it out and give it some time to bake. Another thing is compute resource affinity, and this is, as we start to get into talking about data processing on OpenShift and using, the underlying substrate of Kubernetes to kind of like bring these things together, it becomes difficult because by default, these things will just be kind of wide open and they'll be allowed to have as much compute resources as they want on the host that they're running on. And because Spark runs out of the JVM, what we see is, you could run one pod on a machine, and if it's not constrained, you look at the pod and the JVM thinks it's got 40 cores and half a terabyte of RAM. Okay, that's not so good. So as you start to deploy these into like kind of production modes, you're really gonna have to look into, how do we constrain each of the pods we're deploying? Are we going to use node labeling, or are we going to use the kind of up-and-coming CPU slices to tell it only let this pod have this much? Maybe we need to constrain the memory of the pod so that I don't put a really noisy pod onto one of my nodes, and all of a sudden nothing else can work there.
So as the OpenShift guy, there are quotas already available in OpenShift. So even though the JVM may be reading the wrong information, like it thinks it has the whole machine, you can still stop it right now, today, from exhausting that quota all on its own. You just say, this pod is only allowed to consume, since we're dealing with Java, this pod is only allowed to consume 5 gigs of data, memory, right? So it will think it has more, but it will hit up against 5 and we'll stop it.
Right.
And the other thing that you can also do, and this is with labeling, if you have part of your cluster where you've got like high CPU machines with dedicated IOPS and all that, like really fast disks and all that stuff, you can actually label the nodes to be like high compute. And then when you spin up the pods, you can tell those pods you are only allowed to spin up on high compute nodes. So that you can say, like, I don't want to spin that up on some other part of the cluster where it's not going to be performant, or I paid all this good money for those really big compute machines. I want to make sure the right things end up on them. And you can do that today inside of OpenShift as well.
Right. And this becomes a really big issue when we talk about analytics because, yeah, maybe you bought some expensive machines that are loaded with GPUs, and you don't want your job landing on a machine that doesn't have a GPU at that point, right?
That's right. Well, and that's coming in Kubernetes. So Kubernetes, I think it's an alpha state right now. It can pass through the GPU to the actual pods and schedule based on them. When that goes into beta, it'll probably be fully supported in OpenShift. It's probably there right now, and you can play with it, but don't call if it doesn't work, because it's not supported yet, okay?
Right, so in a similar vein though, persistent storage is also something that requires a little more coordination, especially if you're using kind of the Kubernetes persistent volumes objects that are there for you, because you're, at that point, as a developer coming into OpenShift, it's great to have all these resources and I can just start spawning things and I'm making infrastructure and I don't need to talk to anybody else. I've got a database, I've got a Spark cluster, but when we start talking about persistent storage, if I'm not using some sort of cloud-based storage, now I'm going to have to get ops involved. I'm going to have to get the infrastructure team involved and say, hey, I need some persistent storage. So this is just going to require more coordination. It's not impossible. It's just these are things where you're going to start to get deeper into how many extra pieces you'll have to bring in.
But that's the ops problem. So Kubernetes basically has a pluggable architecture, and OpenShift has a pluggable architecture for storage. And so you say, this is going to be fast disk stuff. I need you to provision an iSCSI device to the OpenShift cluster. And they'll attach it to the cluster, and then you as the developer, either as the data scientist or the web developer, can then make claims into that iSCSI device. Once they do their job, you don't have to talk to them again, I promise.
Okay, so great. We've made our app and everything. What about the DevOps? How do we get into this cycle, this continuous integration and deployment cycle? We go from, coding, testing to deploying.
3 minutes.
3 minutes?
Yeah, so if we need to skip slides, let's skip.
Okay, so
let's get to the wrap up because everybody's going to start walking out.
So for those of you who have used OpenShift, you guys are aware that you can take code directly from GitHub or your repository and have it rebuild. And the idea here is that we could improve the process by allowing our developers to push to Git, and then for every commit that happens in Git, we get Jenkins involved to run like our automated testing or perhaps another framework. And there's great Jenkins tooling inside of OpenShift and kind of workflow pipelines you can get into. And then once they've passed the test, now we can say, all right, let these things automatically deploy into our projects so that as a developer, if Steve and I are both working on the front end part, and we're both making changes and pushing them to Git, we know that they'll only make it into the project once they've passed the testing. And then the next part is, all right, how do we take that architecture we've just been working on, and how do we start to go to the next level, taking it from development into production, right? Because before we look on the left, we've still got our mock server in there, and this stuff happening over here isn't really real yet, right? So what we might do is we might create more projects to help us kind of help us segregate when these things migrate from development into production. So these are our development projects where a lot of the work is going on. But once they've passed, kind of our release cycle and we're ready to put it into production, maybe we'll put it into an integration project where we can put all the pieces together from both of these along with the real, database backend.
We're cut off.
Okay.
So let's do our summary slide.
All right. Test drive it. Go to redanalytics.io.
This is where you take your camera out and take a picture because you want to know that URL. I don't want you going home and being sad.
Yeah, the code samples and everything you saw that we did here today it's in there. We've also got tutorials, projects, everything you need to get started running Spark on your OpenShift like this evening when you're at the baseball game.
Exactly, because I'm from New York. Because we all know it's going to be a boring game. What good could come out of the Red Sox playing baseball?
So, all right, are there any other questions?
We don't have time for them anyway, so you'll have to catch us afterwards.
All right. Well,
thanks, everybody.
Yeah.